Hey, welcome back, you crazy cats. Today we're going to learn about some more work with calculating potential and kinetic energy. We're going to be able to differentiate between different forms of potential energy. We're going to discuss a little bit more how energy is conserved and how to identify internal energy and how to identify mechanical energy. Okay, a 25-gram pendulum is swinging back and forth. It was let go from a height of 10 meters. So we're going to have, when it's up here at the top, it's going to come to a stop. So velocity would be 0. So it would be all potential energy, 100% potential energy. Likewise, once it swings down right here, it's going to have height is going to be 0. So all of this potential energy is going to be converted into kinetic energy. And then as it starts to swing back up, once it gets up to this point again when the velocity equals 0 because the gravity is pulling on it, it's going to have made that conversion back to potential energy. Well, they want us to find its velocity at the following heights. So let's find out how much maximum potential energy, and then we can start to convert it. We can find out how much potential energy it's lost and how much kinetic energy it must have gained or transferred, whichever word you want to use. So I'm going to start here at 10 meters. The potential energy at the 10 meter mark is going to be mass times gravity times height, and in this case the mass is going to be 0.025, if I convert grams into kilograms, times 9.8 times the height of 10 meters. And our potential energy then at 10 meters is, hopefully you guys are pausing this and trying to find your own answers to make sure that you can do this on your own, but this would be 2.45 joules. That's how much potential energy this pendulum has at the 10 meter mark. So that's why I got 10 here for the height. So I'm going to start here at the 0 meter mark. So once that's all the way down here, height is 0. Well, we've learned that 100% of the kinetic energy then at that point is going to, or 100% of the potential energy has been transferred into kinetic energy. So here I can simply say that the kinetic energy is 1/2 mv squared. In this case, that's going to be 2.45 equals 1/2. The mass is 0.025. And then the velocity is what we're going to solve for. Hopefully, again, you're pausing this so you can find these answers on your own. But the velocity then is 14 meters per second. And that's at the 0 meter mark. That's the fastest it's going to be going. The next easiest one here, I think, is this 5 meter mark. Well, that's halfway down. So that means half of this potential energy is going to have converted or transferred into kinetic energy. So half of 2.45 would be 1.225. So again, I can use this same kinetic energy equation, and 1.225. Now again, you could be pausing it and trying to do this on your own. 1/2, the mass is 0.025 v squared. And a lot of you might have been thinking the velocity was going to be 7 meters per second, but that's not true because of the squared here, and we get an answer of 9.9 meters per second. Now let's do the last one, 1 meter. Well, that means that it only has, I'm going to do this by finding out how much potential energy is left. Well, the potential energy is going to be the 0.025 times 9.8 times 1. We find out that it still has 0.245 joules of potential energy. That means that our all of the energy, I'm going to put down mechanical energy, is equal to potential energy plus the kinetic energy here. Well, potential energy is 0.245 plus however much kinetic energy has to be equal to the original 2.45. We can't lose, so it all has to be made up somewhere. We could say internal energy over here as well, but we're going to assume that there's no internal energy here. So the kinetic energy The kinetic energy in this case then is 2.205 joules. And then I would repeat this process over here of putting it into our kinetic energy equation and solving for the velocity. Well, I'm not going to do that. So right here, I want you to make sure, I've done several on your own, or several for you, I want you to work out this one on your own. Again, if you didn't stop and pause it, you should stop and pause it and work out that last one from the 1 meter mark. Energy of a spring. A pogo stick is designed so that a 20 kilogram drill dropping from 0.4 meters will compress the spring by 12 centimeters. What must be the constant of the spring? Actually, we did this one in class the other day, so I'm not going to repeat that one right now. Let's go on to this one. Alright, a rocket, 188 grams, is shot straight up from the ground. It is launched with 15 newtons. The impulse is going to last for 0.75 seconds. The rocket's cap never pops off, and it carries up into the sky before dive bombing back to Earth. Find the velocity at the end of impulse. Well, they tell us that the impulse lasts 0.75 seconds. So my time, 0.75 seconds. I know that my mass is equal to 0.188 kilograms, and that the force is 15 newtons. So we could say then that the velocity, Vf equals Vi plus At. I know that Vi is 0. I know that the time is 0.75. What I don't know is the acceleration. But I do know that the force is 15 newtons. So if I say force equals mass times acceleration, force is 15, the mass is 0.188, and we can solve for A. You should be using a calculator. Just sitting here writing this down is not going to do you any good. The acceleration then is equal to 79.8 meters per second squared. So Vf here is equal to 79.8 times 0.75. So Vf is going to be equal to 59.9 meters per second. So at the end of impulse, this rocket is now going this much speed. I'm going to skip number 3 because we just talked about speed. It says find the kinetic energy at this point. Well, the kinetic energy is 1/2 mv squared. So that's going to be 1/2. The mass is 0.188 and their velocity is 59.9 squared. Find that kinetic energy. Pause it. Find it. Okay, hopefully you guys paused it. And when you did that, you got a kinetic energy that was equal to 337.3 joules. Now let's go back to the potential energy of the rocket at this point. To find the potential energy, we've got to use mass, gravity, and height. We're going to use gravity and height because it's gravitational potential energy we're talking about here because of its height. We know its mass. Mass is 0.188. Gravity is 9.8. What we got to find here now is height. Well, I'm going to go back to one of our kinematic equations. See if I can do this without messing up the paper here, or messing up the screen. Yf equals Yi plus Vit plus 1/2 At squared. Well, to find the height, Yi goes 0, Vi goes to 0, and we can say that Yf equals 1/2 times our acceleration of 79.9 or 79.8 and then 0.75 squared. So running out of time here a little bit. Yf is 22.4 meters. So I have mass, gravity, and height. And we find out when we multiply that, the potential energy is 41.4 joules. Find the expected height of the rocket. Well, to find the expected height of the rocket, it tells me that the kinetic energy is 337.3. What is all of this kinetic energy going to do? It's going to be converted into potential energy. As it loses speed, it's going to be gaining height. So I would say that my total energy is going to be the potential energy it has already plus the kinetic energy that it currently has. Because again, all of this kinetic energy is going to be slowly transferring into potential energy, much the same way the pendulum did earlier. So my total potential energy is 337 plus 41.4. That gives me 378.7 joules. I would use mgh. I know the mass, I know gravity, find the height. And that's going to tell us the expected height. I want you to go ahead and find that on your own. Then we have numbers 5 and 6. And that's what I'm going to leave you with trying to solve for. Then I want you to give this a crack. I'm not going to work through it here. I want you to try to do this one. I will tell you that the 20 kilogram bullet, you need to change this into kilograms. 500 meters per second hits a motionless 3 kilogram target. Find the new velocity of the bullet and target. I would use momentum equations. The momentum before, momentum after. We're going to assume that it hits this target and they become one mass. An inelastic collision. Internal energy. Well, think of this as our total mechanical energy. A little bit more close to what we're going to talk about in class. You're going to have a velocity of the two. So that's going to be kinetic energy. There's not going to be any potential energy, so you can get rid of this. And we're going to have this missing energy. And that's going to be your internal energy. Well, hey, I hope this was informational. Oh, sorry, we got one last thing I want you to do as well. Right, one paragraph. Professor hangs a bowling ball from the ceiling. He pulls it back to his nose and releases it. Is any danger of needing plastic surgery? Why? Suppose he pushes the ball. Why? So, go ahead and answer this. Doesn't need to be a huge elaborate, but we should be talking about potential energy and kinetic energy and the transfer of one to the other as you're answering this. If you're not using those terms in your answer or in your essay, you're probably not doing a very good job. Hopefully you guys are going to do a great job. I'll catch you on the flip side.